Good morning, friends. Welcome to Water Resources Engineering class. So, we are now dealing with Unit 3. Unit 3 refers to hydrographs. So, what we have studied in Unit 3 till now, if I see it, first we have started with what is hydrograph, then what are the components of hydrograph, right? And then what are the characteristics of hydrograph, what are the factors affecting hydrograph, so these are the first things that which we have taken up. Then next one we have taken up is how to derive direct runoff hydrograph from storm hydrograph ordinates. So this is, here comes actually the separation of base flow. That is one important thing. There are three methods here and we have done it, and by separating it from the storm hydrograph, if you separate it, then we get direct runoff. So direct runoff ordinates are equal to storm hydrograph ordinates minus base flow. This is one. Then next point what we have studied is what is depth of direct runoff. Depth of direct runoff or rainfall excess. Anything is same, it is equal to 0.36 into sigma O into T divided by A. This is the next thing. Then fourth one, we started with what is unit hydrograph. This is next. How to construct UH, that was the next we have taken. For constructing UH, how to do it? So first thing is direct runoff hydrograph ordinates, then find the depth of direct runoff. So these ordinates by depth of direct runoff will give you unit hydrograph ordinates. So this is one particular aspect. Then afterwards, then naturally these applications of unit hydrograph, assumptions of unit hydrograph, limitations of unit hydrograph, all that we have studied. Then what we have next taken up is, if you see it, how to get actually UH of, let us say, some time duration from a given UH of some time duration. So there are two methods here. One is superposition method. Second one is S-curve method. So these two also we have dealt with, and when each one is used also we have studied. Superposition is used only if suppose a given UH is of shorter duration and required UH is of longer duration, and that too the required UH duration is a multiple of the given unit hydrograph duration, then this is applicable. Otherwise, in all the other circumstances, S-curve method. But what is critical point in the S-curve method? The first thing that you should remember is the time interval, that is very crucial, which you should think of. Then after this actually, then next we have gone actually how to really, if suppose a complex hydrograph is given, determine UH ordinates, that is what the next. So that also we have completed actually. So after completing all these lectures, now we are in the next lecture, lecture 7 actually. What in this lecture we will focus upon? In this lecture we focus on the thing is, now UH is given to you, UH is given, find storm hydrograph. This is what we have done. Previously storm hydrograph is given, I found UH. Now UH is given, find the storm hydrograph. Almost it appears to be from this end to this end, same application from this to this. So this we will take it up in today's class. So in today's class, the main focus is unit hydrograph of some duration is given to you and you are asked to find out what is the storm hydrograph ordinates. That is our lecture actually. So now let us see. So application of unit hydrograph to the construction of flood hydrograph. A flood hydrograph or storm hydrograph both are same. Given is unit hydrograph, construction required is the flood hydrograph or storm hydrograph. So what is the thing first? Collect the data, required data, whatever is required. So once you collect the data, and all this step 1 include what you need to determine from the entire step 1. You need to find out what is rainfall excess. This is our first thing. So based on the given data, whatever is given, try to find out what is the rainfall excess. That is your first target, right? If that you find, then most of the things are slowly we can take it up. In order to determine that, what we need to do and all, take the hydrograph data, okay? Then from the hydrograph data, divide it into uniform storm duration blocks. So 1 hour or 3 hour or 6 hours that you take it and determine the effective rainfall or rainfall excess. The entire first step is for this particular thing. And second step is determine the, second step is also same first one. Then third step is what actually find out the appropriate unit hydrograph for the given data actually. So that means what is that actually, if suppose 3 hour unit hydrograph data is given, then naturally you have to find out the effective rainfall for a 3 hour storm actually. So this you should take it. Then coming to next one, what is multiply by the unit hydrograph ordinate into the rainfall excess is equal to the rainfall excess will give you basically what it will give you. It gives you direct runoff ordinates. That is what the next step is completely. Please go through this step completely. This is all this. So unit hydrograph ordinates multiplied by rainfall excess is equal to depth of the direct runoff ordinate. That's what you have done it also previously, right? Once that is done, add the base flow actually. So now whatever DRO plus base flow is equal to this is storm hydrograph ordinates or flood hydrograph ordinate. So that's all basically. So previously we started flood hydrograph ordinate minus base flow, then divided by depth of direct runoff, UH is obtained. That is what we have done. So while previous one, if you just recollect once, what is given? Storm hydrograph is given to you. From the storm hydrograph, what we have done? You have subtracted base flow and you find out direct runoff. Then from direct runoff, what we have done it is equal to, you find out depth of direct runoff. Depth of direct runoff is nothing but rainfall excess. That is what you found. Then naturally UH ordinate is equal to the DRO divided by the depth, the rainfall excess. This is the thing. This is what we have done in the beginning. So now what I am asking, UHO is given. So this is given. From this actually what you need to find out actually the rainfall excess. Once the rainfall excess is found, you reach it. From UH is given. From here to here you found rainfall excess. Once this is there, then naturally DRO is equal to, it is equal to UH ordinate into the rainfall excess, right? Then SHO is equal to DRO plus base flow. So previously we have done from storm hydrograph to unit hydrograph, now from unit hydrograph to storm hydrograph. But you should be careful while doing the problems. Explanation is very, very simple while doing it, but kindly as I take up the problems one after the other, you understand where the crux is actually. Summary, once again you see it, effective rainfall, this is what they will give you or you need to calculate. Choose the matching UH that will be given to you in the exam. then actually effective rainfall and UH you can determine. So then that is direct runoff. Direct runoff afterwards base flow. Then find out what is the flood hydrograph. So first step is find the rainfall excess, then find the DRO. Third one is add base flow. Final one is ordinates of flood hydrograph. So these are the steps you need to follow. Let us take the problem. Now this is the time you need to concentrate on the thing. The ordinates of 3-hour UH. So what is given to you actually? 3-hour UH ordinates given. This is the first thing. Then in time interval is how much actually? 6 hours. Then ordinates are derive the storm hydrograph due to a 3-hour storm. Storm duration is 3-hour storm. Right, with a total rainfall of 15 centimeter. This is rainfall. Assume initial loss of 0.5 centimeter, that is first actually, and phi index of 1 centimeter per hour. Phi index is a loss, infiltration loss. Initial loss is due to interception, due to depression storage, whatever it is, that is first thing. So these two are losses. Of course, base flow is also given. So what is my first step actually? Find the rainfall excess. Find the rainfall excess. Rainfall excess or depth of direct runoff. Anything is same. How to get it? Total rainfall minus losses. Total rainfall is how much actually? 15 centimeters. Minus losses is how much? First initial loss is 0.5 centimeters minus phi index 1 centimeter per hour. But storm is for how many hours actually? Storm is how many hours? Storm is for 3 hours. So naturally 1 into 3. So naturally 15 minus 3.5. So it is 11.5 centimeters. So this is what I found here. Kindly check it up. How to get the rainfall excess is rainfall minus losses. There you need to be very cautious. Clearly you should see the data and accordingly you need to calculate. Once this rainfall excess is over, then I see. I have taken whatever is the time interval given, what is the unit hydrograph given also. Then I put what is the depth of direct runoff or rainfall excess. Right? This is 11.5. I have put it. Now what I need to do, this multiplied by UH ordinate is equal to depth of direct runoff. So direct runoff ordinate is equal to UH ordinate into depth of direct runoff. This already you know it because previously you calculated UHO is equal to DRO divided by depth of direct runoff. The same thing I have written here. So this is the next thing. So I have applied this. So UHO into 11.5. So ordinates you can see. So these are all DRO ordinates. That means direct runoff ordinates. So after direct runoff ordinates, base flow. Base flow he has given. So direct runoff ordinates plus base flow is equal to flood hydrograph. You understood? In the beginning, flood hydrograph is given. You subtracted it. You got this. And then you found this much, how much actually, then you divided by this, you got this. So previously, you worked like this actually. Now what I am asking, we have given this and you are asked to do this way. Method is same, only how here. So direct runoff ordinate is equal to UH ordinate into depth of direct runoff. Flood hydrograph ordinate is equal to direct runoff ordinate plus base flow. Now a little bit, we will increase the difficulty level. Ordinates of 3-hour UH is given, right? Determine the direct runoff hydrograph due to 2 effective rainfall pulses. How many effective rainfalls? 2 effective rainfalls. Please remember, 2 centimeters, 3 centimeters occurring in 2 successive hour duration. That means in the first 3 hours, 2 centimeters is the rainfall. In the next 3 hours, 3 centimeters is the basically the rainfall. So that means there are 2 storms. In the previous problem, there is only 1 storm. Now how many storms are there? This is first storm, this is second storm. So first storm, second storm. right? And he has already given as rainfall excess. If you see 2 ER pulses, that means effective rainfall pulses. That means losses have been subtracted and that only he has given it. Understood? Right. Now what should I do? First one I will take it. First one is 2 centimeters. So this multiplied by UH ordinates, I have put it. This is how I got it. It's as usual like previous problem. So the direct runoff ordinate is equal to UH ordinate into depth of direct runoff. That's what I have done. But this is not one storm. There is second storm also. But when the second storm will occur? The second storm will occur after 3 hours. So in the first 3 hours, there is no storm actually here. The second storm has occurred after 3 hours. So if I take the same thing after 3 hours, that means this UH ordinate into the rainfall excess 3, then this represents this. UH ordinate into 2, this represents this. This is beginning and this is after 3 hours. That after 3 hours showing, I have done it by like this. So now if you add both the things together, you will get this. He asked only direct runoff ordinates. He did not ask storm hydrograph ordinates because he has not given the base flow. So you cannot calculate the flood hydrograph ordinates. So now here how many rainfalls are there? There are 2 rainfalls actually. So one is 2 centimeter, one is 3 centimeter. 2 centimeter is first 3 hours, 3 centimeters is the next 3 hours. So that is why the first storm has occurred completely. The second storm, when it started, after 3 hours. That's why after 3 hours. Now if you sum it up, you get the direct runoff ordinates. So this is second problem, a little bit difficult. Third problem I will show you. Now this is generally, normally, if you are able to understand this problem, then any problem you can solve it. I started with the introduction of the principle in the first problem. Second problem, I brought in the second rainfall also, so that how to really see that all rainfalls will not occur at the same time, one after the other. So that's what I showed in the second thing actually. Now this is wherein everything you can take into account and do the things. Now how many storms are here? There are 3 storms. 3 storms, one is 2 centimeter, 5.75 and 2.75 centimeter. So 3 basically storms have occurred subsequent 3 hour intervals. So the first storm has started at 0 time, second storm has started at 3 hours time, third storm has started at 6 hours time. So this you should remember by the first sentence. Second, ordinates of the unit hydrograph are given actually at 3 hour interval. Fine, no issues. Then assume initial loss 0.5. This is very important. Then infiltration rate also he has given and base flow also given. Total. Now everything has come. You need to find out effective rainfall. You need to find out basically the flood hydrograph also. So complete problem is this. And how many storms are there? 3 storms. The storms, if I just draw here, the first storm is how much actually? If I take it, it is 2 centimeter. And the second one is how much actually? 5.75. This is second. And third one is how much? 2.75. This is third. So each one, this is 0, 3, 6, 9. So this is 2.75 and this is basically 5.75 and this is basically 2.75. 3 storms are the 2. So 3 are there actually for us. So this we are supposed to deal with it. Now closely watch. Now what is my first step? Find out the rainfall excess. How to find the rainfall excess? I will show. Take the first storm. First storm rainfall is how much? So rainfall is equal to, first storm only I am showing it to you, 2 centimeters. So initial loss is how much? Minus 0.5. Then what is infiltration rate? 0.25 centimeter per hour. Time is how much? 3. So if I take 2 minus 0.5 minus 0.25 into 3, naturally 0.75. So this is the rainfall excess due to first storm. Similarly, second storm, if I take it, how much? 5.75. Here I did not delete the initial loss. Initial loss will not occur for every storm. Initial loss means at the beginning of the first storm, only initial loss will be there. Once the storm is continuing, in the first 3 hours, it is 2.75 centimeters. In next 3 hours, it is 5.75 centimeters. Next 3 hours, it is 2 centimeters. So naturally, initial loss will not be there for every storm. Initial loss will be there only for the first storm. So that's why when you are doing this for the second storm, when you are finding out the rainfall excess, this minus 0.5 is not there at all. That will be only for the first storm. So rest is same. My 0.25 into 3. So calculate. Third storm is 2.75 minus this 0.5 is not there at all. 0.5 is only for the first storm. Minus 0.25 into 3. So if I do it the same, I found 0.75 centimeters, 5 centimeters and 2 centimeters. That's what. Now I have made it time, first column. Second column is UH ordinate. Third column is, this is rainfall. This is not there. It is rainfall. Just rainfall excess. Rainfall excess is equal to, this is first storm, this is second storm, this is third storm. So this is the first thing you need to complete. Then next table is there in the next page, don't worry. So now I will start with the first storm. First storm start initially. So this ordinate UHO, this how I am getting this, it is UHO into 0.75. This is what I have put, I got it. The second one will start at what time? After 3 hours. That's why this is there. So again after here. So what is the effective rainfall? 5 into, I have put it, I have shown also. Same, that continues. Third storm, when it will start? After 6 hours. So first G nothing, second nothing. From third it starts. That's the thing. And now total base flow minus storm hydrograph ordinates. Now you see it thing, I have done it. So only difference is here, first storm starts at beginning, right? First storm at beginning. Second storm after 3 hours, right? Third storm after 3 hours of second storm or after 6 hours. Anything is fine. So each one occurs one after the other. All the rainfalls are not occurring simultaneously. They are occurring successively one after the other. That is what I am. Rest of the steps are same. Direct runoff ordinate is equal to UH ordinate into rainfall excess, and then add it up. That is total direct runoff plus base flow, storm hydrograph. This is the, so this is one of the very, very important problem, because this step 2 is very crucial and the rest is also very crucial. So kindly work on this type of problems. With this, I have completed this topic, how to really derive a complex hydrograph or a flood hydrograph from a given unit hydrograph. Thank you so much. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.